Our next speaker began his life studying metallurgy, melted metal and stuff. That led to him interested in design, spending some time with Adobe Flash, which led to developing and coding, which led to time at Meta. Spent almost a decade there, and then came to then left and founded a startup. Guess what his startup's doing? AI, thank you. Of course it is. And so he's here to tell you 8 patterns to scale on-device models. Please welcome Sash.
All right. Hey. Is it on? Yes. Hello. Hi, all. First of all, thanks so much to organizers. This has been an incredible conference, and every time, this is not the first time coming here, and wonderful, wonderful people, wonderful talks, incredible wine. Maybe a bit too much. I want to talk to you about foundation models, and congrats, this is the last AI talk of the conference. How exciting. And so, if you had a chance to attend a workshop at the beginning of the conference, you probably learned a lot about foundation models and how they're great, and they have great use cases on devices. And it's one of the few sort of things that Apple is uniquely positioned to do because they own the entire stack. Foundation models come with some limitations. And obviously, me being myself, I will focus on the limitations. But not only that, I will actually talk about not only how foundation model comes short, hence foundational sins, but also how to address that. Maybe some of you heard the story behind Game Boy when Nintendo was about to release it. They called it lateral thinking with withered technologies. And the core idea there was that you take technology that's sort of like, not state-of-the-art, but you combine it in a really interesting way, and, out comes a really great product. So it's very rarely when technology alone is enough. And yeah, as Steve Jobs once said. But yeah, back to foundation models. We're going to talk about 7 ways in which it can be a bit annoying to work with. And I will be switching back and forth with, between slides and demos. And I want to give a bit of a warning. This talk is rated O for oversimplification. There's going to be a lot of hand-waving. The code that you will see on the slides is not the code it should be. Obviously, it's all vibe coded. Later, I will share the actual repository. You will see the actual code. But what I want you to take away from this is mostly the principle, the core idea behind how to combine technologies in a way that sort of like hides, the shortcomings. And those lessons, they came from, some of the projects that I worked on at Meta. I was on Meta AI for the past year and a half. And those are the same principles that you can apply to models on the back end, really powerful models. And off we go. So the very first sin is gluttony. The model is hungry. It goes through the tokens really fast. Not only that, it's limited to 4,000 tokens. I will be assuming some knowledge of LLMs and how they work. There is this concept of context window, and it's basically how much model can ingest information and generate information in there before it just fails with errors. And so in the industry, there is actually a way of dealing with it, because once the model actually runs out of context, it just fails with an error, right? But that's not an experience we want to give to people, to users. And so there is a way to deal with that, and one of them, maybe you saw it if you ever used any sort of cursors or VS Code Copilot. It's called recompacting. And I'll show you a quick demo here. So I'll be switching. Hopefully this is big enough. So I'll skip the vanilla chat just in the interest of time. Basically, it's your classic chat app where I can sort of ask questions, and LLM can generate the answers. And so here I asked, let me actually first kick off the recompaction, and I'll explain what it does in a second because it takes a while. So I asked, generate an essay about horses, and it generated all the text. Then I was generate an essay about dogs, and it generated all the text, and something else, and it generated something else. And you can see here the yellow bar. It was just yellow a second ago. That was showing how much context was actually consumed, and that's because all the text was already there. Now we went through this process of recompaction, and what it did, it basically took all the information there, and it asked a different LLM on the side, write a summary. What did we just talk about? And now I can say, what did we just talk about? And it actually goes and it says, oh, we discussed horses, we discussed dogs and owls and whatever, and it goes and sort of recites the things. But you can see that the context went back, not right to the beginning, but it's sort of like, you know, in a good state. And so basically what happens here is a bit of a sleight of hand. And so I will show you a code behind it and talk through it in a second. Actually, now. So we have some sort of really primitive heuristics when we say, OK, we're about to run out of context, right? This is danger zone, right? Yellow progress bar. Let's take all the chat that we had, create a text representation of that, and just shove it into this separate LLM and ask it to create a summary. And it's basically like if I would be retelling you a film, it produces a summary. And then I set up the main LLM with the summary context, telling it, you know what? We just ran out of context. Here is, you know, the brief description of what just happened. Be aware of that. And then when user asks, you know, any sort of questions related to that, you can actually go ahead and retrieve it from this little summary. So this is one way in which you can pretty much create an infinite context window for even, you know, a relatively limited LLM on device. So every time you come to the end, you can recycle it and go back. In the interest of time, I will be skipping a lot of subtleties and details. I'll also be publishing a bunch of blog posts that go way deeper. There are many different techniques for each one of the problems that I'll be talking about. For now, this is probably good enough. So the next one, you know, there is this whole hype about like text to text. You ask text, out comes text, right? So like this whole desire to see as much text as possible. But even Apple provides us with a few more really interesting tools. So another interesting tool that we had for I think a couple of years now is Image Playground, right? So you write some sort of text and out comes the image. And at some point, they also released a headless version of this API where you can pretty much just provide text and sort of generate the image without even spawning the Apple vanilla sort of UI. And so here, it's another example of the same chat where I'm asking some textual question, and just to illustrate that it still works the same way, but then I can ask, create an image of an owl. And so at this point, what happens, you can see that it changed the indicator. It detected that what I actually want is an image, right? And it went ahead and created the image of the owl. That's all right. But now I can also ask it, what am I looking at? And obviously, live demo failed, and it thinks that I wanted another image. What am I looking at? Oh, God damn it. Describe. I love that the images get longer and longer. OK, this is going to be tricky. Yeah, OK, so let me try this again, maybe. Create an image of a dog. I see. OK. Cool. Yeah. Yeah, so as you can see, this is a state-of-the-art technology. And let me try one last time, and then I'll just have to switch to the code sample instead of an owl. Describe it. Thank God. Jesus. OK, so really, the bar is that low. When it works, applause. Anyway, but the interesting point, obviously, when it works, is that we not only detected sometimes overly zealous when we need to generate the images, but then we can actually ask what exactly are we looking at. And so you know that language model doesn't really have this capability, right? So what exactly did we do here? Because it describes it in a pretty precise details, and I'll say it perching on a branch, you know, yada yada, like all this stuff. And so we basically use this interesting modality of language model that's called content tagging. And it allows you to basically detect intent when it works. And you can actually structure it just like your regular prompt. You can define some sort of custom structs and data types to actually receive more structured result than just a text. And so it detects that we want to generate an image. And so when we detect it in our code, we switch to this other route that has to do with image playground APIs. And we not only we do that, we do this expansion of the prompt. So create an image of the owl is a pretty sort of constrained prompt. We want to add more details. It's been shown that it often results in way, way better sort of image quality. And so we ask a separate LLM to just expand, add more details, describe what it would look like, right? And then we take this synthetic prompt, we put it into image playground, out comes the image. Not only that, then we take a vision kit, yet another technology that Apple provides, and we sort of ingest the image combined with the original prompt, and we ask it to synthesize, describe what are you looking at, and then synthesize the proper description between the user prompt, between the image, synthesize them both. And then we inject a message of type image with a description. And to the language model, we tell, there is an image here, you cannot see it, but here's the description. And so that's how we can ask about it. And again, I understand the irony when this stuff doesn't work, but we can ask it, and it can actually tell us, OK, this is what you actually generated. You can also ask follow-ups, like add another bird or whatever, and it will sort of understand what you're referring to, because it will try to resolve all of that with the text that it has. All right, pride. So LLMs are known to be very proud when it comes to asking questions. They love to hallucinate, even you ask something that they don't know. They just want to show up in the best light and tell you they know everything. But they have this concept of the cutoff date, and that's basically when they sealed the actual LLM. And so it doesn't know about most recent developments. It doesn't know the news. It doesn't know, for example, SF symbols that Apple just shipped with the latest sort of OS. And so here, what I'm saying find an icon for happiness, right? And so, hoping that it's going to work. OK, that works. So what it did here, it actually looked through SF symbols. And funny enough, if you actually open SF Symbols app and you search for happiness, you will not find happiness in SF Symbols. And the reason, so the way it works is that Apple ships names of SF symbols, but it also ships a list of synonyms. And so the search, when you search for share and it shows the rectangle with arrow pointing up, it uses synonyms to understand that. But then what we're doing here, we're doing so-called RAG. And RAG is this concept that helps LLMs to ground their knowledge in the specific information. The exact details are sort of like way beyond of the scope of the conversation. I'll show some handy wavy slides. And so it goes like that. First one, we create a tool. LLMs can use tools. We create a tool that will be in charge of searching SF symbols, right? And so again, when this works well, the system prompt and the tool description is enough for LLM to detect the intent. So I wanted to find an icon, and it sees that it has a tool that sort of like works with that. So it just asks it to find it. And then it's up to the tool to actually know how to find it. Then it generates structured response. We find that there are symbols associated with response. If it found them, we render them, yada, yada. Let's take a look at the tool itself. Again, it's very simple for the sort of sake of the illustration. But again, we sort of give it a name. We give some description so that it can match against that. And we kick off this symbol index. The next slide is going to be intimidating. And that's OK. You don't need to worry about it. It's intimidating. So there is this concept of embeddings, right? So like high level, this story goes like that. When you search Command F for text, you find the exact text that you found, maybe case sensitive, maybe regular expressions, but it doesn't really find semantic meaning. So if you search for a puppy and your document has a word dog, it will not find it. But that's where semantic search comes in. And one of the ways to implement it is through embeddings. You basically explode words into this multidimensional space where they all clustered. And puppy and a dog would be close to each other, and puppy and a cat would be a bit further apart. And so then you can take two words in this multidimensional space and sort of ask, how far apart are they? And compare them all. And the ones that are close together, you can say, OK, they're clustered, so they must be relevant. In this example, I'm also demonstrating another technique, which is BM25 search. Crazy stuff. I wanted to show up as a very smart person. We're going to ignore it for the sake of time. The core idea is that we take the query that LLM receives from the user, in our case it was happiness, and it goes and searches through all the embeddings for SF symbol synonyms, and it just tries to figure out what was actually there. And so here you can see there is heart, smiley face, like people holding hands. So it's like all the stuff that's going to make sense. And I mean, like some of them are probably going to be faulty, and you can tweak it to be a bit more precise. But the core idea is that it takes concepts that live close together, and it draws the line somewhere and says, okay, those are actually relevant concepts. And so this is the way you can tell your LLM, okay, let's ground you in the data that you don't know, but we give you a tool to search for it. This is the basic concept of RAG. Envy. Okay, so it's been sort of said multiple times in this conference that this technology is sort of inherently probabilistic. It means that the answers that we're getting, they're like coin toss left and right. And so you ask model multiple times, you get multiple answers. There's this notion of temperature outside of the scope, again. And so when you ask models complex questions that it should be able to answer from its own knowledge, if you ask it multiple times, it will give you multiple different answers, and it's likely that one of them is better than the other, right? And so there is this technique that's called majority voting, when you literally just ask it multiple times, and then you have a separate LLM that is so-called judge, and you ask it, which one is better? Here is the user question, here are the answers, which one is better? And this is the concept behind majority voting. So for majority voting, I'm asking what is love, and everyone knows that baby didn't hurt me is love. And so you saw that it switched to 5 dots really briefly. That's because it detected that it's a hard question and it needs to summon the judges. And it gave the answer, love is an intense feeling of deep affection and care, which sounds pretty reasonable. But then I added this element to the UI that says, OK, here are the different answers that it generated. And actually, the judge down below says the rationale that answer B is concise and actually directly addresses the question. And again, like there is some, I can see the irony how there is no way to find the right answer for what love is. So, but whatever. This is just, again, to illustrate the point. Yeah, the basic idea is super simple. We do some sort of detection of, is this query complex, for whatever that means in your product. And in this example, again, just for the brevity, I spin off 3 parallel questions. I take not just the user query, but like some window below the question. And that is to do with context. We sort of want to give a bit more information to LLM. So if you have like ongoing conversation, it helps to understand a bit better what is the user actually asking about. And then we run it sort of in parallel. And once we get all the results back, we ask the judge, here's the original user question, here are the 3 answers, which one do you think is the best, right? And so then we get back the actual response and the judgment, so like basically why does LLM think that one of them is better? So this is a way to get whatever is meaningful in your product, like whatever the meaning of a better answer in your product for probabilistic systems. Next, so make me say it one more time. So LLMs are sort of traditionally stateless. Right? This is why if you ever worked with like OpenAI, like any API, you need to send them the entire chat every time. And yeah, like OpenAI released like new responses API, whatever, that like sort of maintains state for you. But the technology itself is stateless. It means that every time you ask it, it knows nothing. It just remembers what it was trained on, and that's it. And so this is a bit problematic when you deal with real people, because people like to be remembered. They have preferences. They have some questions that they already asked, answers that they already gave. So like we don't want to keep forcing people to answer that over and over again. And so for that, there is this concept of memory. Needless to say that this is also a research field of its own, and there are a lot of approaches and a lot of ways to deal with that. I deal with it through a text file, because, yeah. And so here, I already sort of talked to this LLM before, and so I asked a few things, I told it a few things, and so at some point, it wrote down some memories, and I show memories on the right side, where it knows that my favorite color is blue, and I used to love Paris, but now I love Logroño. And so here, if I ask it what my favorite city is, it tells me Logroño, and I was like, what about Paris? And it's like, you love Paris, but the actual favorite city is Logroño, and you can ask, do I like color yellow? Well, great, it doesn't have. What is my favorite color? Your favorite color is blue. And so you can, and I can say, no, actually, it is yellow, whatever. And so here you can see that it actually went and updated the memory. So next time I boot this up again, you can actually use this to look it up. And so I'll show you sort of rough sketch of how you can do that. Here we have two tools, the write tool and the read tool. And we basically just rely on, again, on description of the tools for LLM to know when to invoke them. So pretty simple. And then that was like a simple approach. So then LLM will invoke tools whenever is needed. The other, a bit trickier approach, but it gives you a bit more control because you don't trust LLM to like call tools when you think is necessary. You can actually do the detection on the user query and say, is this query requiring some sort of memory operation, right? And then if we detected that, yeah, it actually requires reading memory, we can say, OK, cool, memory store, get me the user prompt. And again, here we can use some sort of embedding search, whatever we want, whatever brings back the relevant memories. And so then what I'm doing, when we actually send the request down to LLM, we prepend the relevant memories, right? So this is, again, like one of the tricks that you can pull. There are many, many ways to address this. This is one of them. Once we get the response, we also, after that, we check, was the actual sort of response something that we need to memorize? And so there is a lot to be said here about what you need and shouldn't memorize about user queries, because there are privacy questions. There is just information that's, sort of might be not something that you want to store outside of the scope. But basically, once we know that, like, cool, we want to write it down, we just write it down. And then we render the response as if that's what user wanted to see. So this is a really, really trivial way to deal with this. Again, there are many companies right now being built around memorization and like different approaches, layers, and different ways to recall, et cetera, et cetera. It's a really interesting field because it draws on how people remember things and what's the right way to forget, and et cetera, et cetera. Sloth. OK, so when being lazy is good. So in the examples that I showed you so far, the responses are pretty quick. When they work like almost instantaneously. But obviously, when you actually start building production apps, you have more complex responses coming out. And depending on your use case, you want to cache the responses. But again, sort of it's a question of what do you cache against, right? Because caching is really simple. We all know that. But you just need to know the key against which you need to cache. And so here, semantic caching. So I asked to write me an essay about horses. I really like essays about horses. And so if I ask, write me essay about horses, which is like phrased slightly differently but not too different, it actually spit it out right away. And it said answered from cache, and it found some sort of like really close matching. But if I ask it, write an essay about cats, it will go off and sort of do that. But then once it's done, it will actually look at how complex this response was. And if it was complex enough, if it was passing some sort of heuristic, it will go and cache it. You can see here that it cached this answer for similar prompts because it was complex enough. Yeah, so again, the happy path is that we found some sort of result for the query that user comes with, and we just immediately render it, right? The unhappy path is that we do whatever makes sense in our product to understand, is this a complex query? Is this a query that needs to be cached? And this is actually a place where, again, all the time-sensitive queries, all the sort of privacy-related stuff is really tricky. So like this is on you and your product to figure out what's the right products, what's the right responses to cache. The fact that it has to do with LLMs is no different. If you would be building sort of any other app and you're dealing with caching, you would need to answer the same question. So once we collect some sort of metrics, again, like really handy-wavy, we collect metrics relevant to your products. In this case, it's like actual response and the duration that it took to generate the response. We decide whether we want to cache it or not, and then next time we repeat, rinse and repeat. OK, so this demo, I'll give it a go. Given the Wi-Fi here and given what you saw already, I don't hold my breath. But we're going to pray. So the grid, right? So like you have all those complex problems that we're trying to solve, and we're trying to solve them with one LLM, and it like one-shots the answers, and it's like that's supposedly how it works. Reality is that it's trickier, and this is where agentic stuff is coming to play. And so I'll talk about it in a second. I'll kick off the demo and see if it works. So I asked it the question, how much is the new iPhone? And what it does here, it goes off and it searches honest-to-God internet, right? So like it has, like an agent that knows how to search internet. And so it finds some sort of results on the internet, and it brings them back. And then yet another agent is saying, OK, I'm analyzing the result. I cannot believe that it worked. You have no idea. And so, yes. And so it brings back the results. And actually, depending on the run, depending on its mood, sometimes it brings the results, and it's like, you know what, it wasn't actually enough. I didn't really find the answer to the question that user was asking. And so it goes and searches more, and then eventually it runs out of context, and it's sad. But like here, surprisingly, it works on the first go. I really should have owned this. I should have like, oh yeah, of course, every time. But yeah, you can see that it found the latest prices for the latest iPhone. I haven't checked the prices. Maybe it hallucinated something, but it even cited the sources, right? So like, how bad can it be? So agentic stuff. It's like really hot topic. OK, here's the video because I didn't really believe that it's going to work. OK, the simplest concept of agentic stuff is a while loop. OK, that's all. That's literally all. So you have LLM that you run in a loop, and you ask, like, user asks a question, and you get the answer, and you're like, OK, is this good? Is this a good answer to the question? If no, rinse and repeat. Simplest way you can think about it. That's it. We already done something similar in the previous demo, so that's about it. The more advanced version of the same story, and that's sort of closer to what I showed you just now, is that you have multiple different roles sort of in there. One of the very first role is a planner, and that's basically the brains of the operation. It's the one who hears about user query, and it comes up with a plan. It's like, oh, OK, we need to search for, you don't take the exact query that user provided. If anyone used Perplexity or any other sort of like even Google AI mode, I don't know if that's available in the EU, but who knows. If you use any of that, you will see that the actual queries that they use are not exactly the same as what you ask because they try to adapt it to what's going to yield better results. So this is the planner. Then it sort of calls the web search agents. They go and they search internet. And again, agents is just like a tool, right? Like it goes, it searches internet, gets the results, brings back the results. Next few run in parallel. They fetch individual web pages, and they run through, if you ever use the readability mode on your phone, like it basically does that. It extracts the actual contents of the article, right? And so it has contents of the article, and it sort of summarizes each one of them using the question that user provided. And then it comes back with results back to the planner. And it's like, here are the results. And once it gets all the results, it looks at them and it asks, is this good enough? Or do we need to revise the plan? And so then we have a last chance to insert more steps in the plan if it was not good enough. If like we searched for something, but we didn't find the actual answer on the pages. And so you can also, here I'm using this sort of variable budget, and that means that you don't want this to run indefinitely if like internet just doesn't have answer to your question. You don't want it to like spin and spin and spin. So you want to give it some sort of termination condition no matter what. But eventually, yeah, hopefully it brings back the answer. And on this demo, it brought it on the first try. In the video that I recorded, I'm not going to show you, it actually took it 2 times because on the first try it brought different results and it didn't have prices there and like whatever. Also, it's internet, like you can just fail to fetch, right? And like that's a thing that you need to think about too. OK, the last one is atonement, right? So like how do we prevent all those sins from happening ever again, right? And so here, I will actually switch to Xcode. And so we already saw the talks about how to use AI in unit tests. Now I wanted to talk about how to use unit tests for AI. And so there is this concept of evals, right? And evals stands for evaluations. They can be used in multiple contexts. Here, specifically, I'm talking about, I'll start running this single test so that it takes a second. But basically, it allows you to say, OK, I found a formula, and you saw how much magic it involves. I found a formula that works. Don't breathe, it works. You can actually create a test, codify this formula, and say, because it's a probabilistic technology, I say here it works 66% of the time. And if it works any less than that, it's horrible. And then, so the prompt that I created here is, you're a haiku writer, write a haiku, and then LLM goes and generates the haiku and brings it back, and it does it 10 times in a loop. And I have a separate, like a judge, again, you can start seeing a pattern here, a judge LLM that says, is this text that I'm looking at, is that a haiku, right? And it sort of evaluates it. So then if I switch to bad prompt, it's a bad haiku writer, sometimes it writes sonnets. awful. And so if I rerun this, it will try to do the same thing. And because it writes something that the judge doesn't recognize as haikus, it fails, right? And here it failed 50% of the time because it's sort of like the way I set it up is like sometimes generates a sonnet. So this is a pretty constrained example, but what is it good for? Well, it's good for, obviously you will not write bad prompts. You have like your great prompt that works. But then Apple actually mentioned in WWDC, and it's like sort of fun wisdom of the industry, that every time you upgrade the model, which Apple reserves to do any dot update, they can release a new model, the behavior can change. And you can see how those systems, they need to be a bit, you need to hold their hands here and there. So you really want this kind of unit test sort of proof that says the model updated underneath the behind the scenes, but we actually still get the same output that we wanted to get. And because here in particular, the output is a haiku, which is like, it is a structured output, but not in the way we think about structured things. We need another LLM to tell us, was that right? And it's basically LLMs all the way down. You use one LLM to verify that the other one works, and like, who knows? But basically, this is like more or less how you can verify that your models keep updating. You can switch to a different model provider. Maybe tomorrow, Google is going to be allowed to bring their models and bundle them with every iOS release. You want to be really sure that it works in the same way that you sort of expect it to. And so this is a way to actually do that. Yeah, this is basically the same code that talks about all the same thing. We run the same test 10 times, and we ask, did it work? Did it fail? Count the failures. That's it. That's pretty much it. This is more or less what I wanted to run through really, really quickly. I also wanted to say great thank you to Marcin for Notepad exe, that all those swanky sample codes are generated, and I use it a lot to just prototype the ideas. And so if you want to try it for 50% off, this is your chance. I think Marcin also brought a bunch of CDs, and you can find him after the talk, somewhere over there. Raise your hand. Yes, that's the guy. So you can find him, and he will be happy to give you some free copies of CDs. Who knows what to do with those? But yeah, anyway, that's my story about LLMs and what you can do with them. Thank you for taking the time. I hope that it makes sense, and I will share the source code a bit later. Yeah, thanks so much.
Thank you. So a specific question that came down was, foundation model, can you run multiple requests in parallel on different sessions, or they'd heard that the framework only allows one request at a time?
Yeah, that's right. So I think that on macOS, you can actually run multiple in parallel. I think, yeah, I tried iOS once. I stopped trying iOS, to be honest, because I have my own gripes with it. But I tried it when they released like beta 4 or whatever, and it definitely didn't work in parallel. So this is a problem on mobile. You will need to be clever about how you structure it.
So with Core ML, you could sometimes get back a percentage that says we're this confident of our answer. Can you do that with these language model sessions? Is there a way of getting it? I mean, you jury-rigged and you built your own way of deciding how accurate something was.
Yeah, I think that's tricky. They don't really report too much. Like there's no public API that I found that reports like confidence scores, or not even like the way I was showing the token count. That's really important if you want to keep running your session endlessly. There is no public API for that, so you have to like estimate. And like Apple tells you on one of the forums, it's like roughly 3 to 4 English characters. But then if you use to generate code or like non-Latin languages, no one knows. So like, here be dragons.
Thank you. And the other thing is, you're talking about on-device in most of your examples here. Do you have a rule of thumb of when you would favor on-device versus?
Rarely. I think, yeah, like basically, you have a lot of really good cases. If it's well-defined, scoped case, that's like, think about if you ever used like calendar app that allows you to type in a free-form event and it sort of detects the right things and creates it, you can use it for that. Or if you want to generate like a mini dialogue, I think it's even one of the sample codes that Apple provides, you can use it for that. I think in reality, most of the examples that I showed, I would be like thinking really hard, okay, like what exactly is the use case? But then I was helping a friend who's building like a sort of medical use case, and we talked through like, oh, what is possible, what is not possible. This is definitely would be one of the tools that I would be looking at, because you don't want to ask people to download like 2 gigabytes or whatever model on device. In some cases, it's okay, but not your average user that you like ship through the App Store. So yeah.
Please thank Sash.
Thank you.
Really good.